Okay guys, in this video, we're going to learn how to construct a line or line segment that's perpendicular to another given line or line segment. Okay, so let's just see how we can do that. Let's say I give you a line segment. Let's call this AB. And I give you a random point that lies on AB. Let's call this P. Okay. So now I'm asking you to draw a line segment that's perpendicular to AB and at the same time crosses the point P. How we can do that? So the first step, we put a compass on point P and we choose a suitable radius and draw an arc that cut AB at C and D. Okay, so basically what we're doing here is we're trying to bisect the straight angle APB. AB is a line segment, right? It's a straight line segment. But we know that for a straight line segment, we can think of it as a straight angle, which is an angle that's 180 degrees, right? So what we're doing here, the steps are very similar to the steps we used to construct an angle bisector. Okay, so the first step, we put a compass on point P and we draw an arc that cut PB and AB. So let's call these 2 points let's call the intersections C and D. Let's call it C. Let's call it D. Okay. Next step, we put a compass on C and we choose a suitable radius and we draw an arc. With the same radius, we move the compass to point D and we draw another arc. And these 2 arcs must have an intersection. And now we join these 2 points. Let's call this E. Let's call this intersection E. And now we join these 2 points, PE. Okay. And we're claiming that PE is perpendicular to AB. Like I said many times, following the steps is not difficult. Proving is difficult. Okay. But this one is not that difficult. It's very straightforward. So how to do that? If we join EC and ED, we'll see 2 triangles, CEP and DEP, right? As long as we can prove these 2 triangles are congruent, then we know that angle EPC is equal to angle EPD. And because the angle CPD or APB is a straight angle, it's 180 degrees, right? If angle EPC is equal to angle EPD, then they're both 90 degrees. And so we can prove that EP is perpendicular to CD. Okay, but can we do that? Okay. Remember the first step? The first step, we put the compass on P and we drew an arc, this arc, right? That means CP is equal to DP, right? Because CP and DP, there are 2 radiuses of the same arc. CP is equal to DP. So these 2 are equal, right? What's the second step? We put We put the compass on C and we chose this radius. We drew an arc like this, right? And we use the same radius and we drew an arc like this. That means EC is equal to ED, right? So EC is equal to ED. And at the same time, EP is a shared common side of the two triangles. EP is equal to EP. With all this information, we can conclude that triangle ECP is congruent to triangle EDP. Right? And like I said, because these two triangles are congruent, that means angle EPC is equal to angle EPD is equal to 180 degrees divided by 2, which is 90 degrees. And that's why angle EPD is a right angle. That means EP is perpendicular to AB. This is how we construct line segment that's perpendicular to the given line segment given a point. Okay, and we also need to know how to prove it. Okay, so this is the all the details that we need to know. Okay, this is this question. Now we need to know, like we need to learn how to construct a line segment that's perpendicular to a given line segment. And the line segment has to pass through a point that's not on the given line segment. Okay, so it sounds confusing, but let's try to draw it. Okay, so let's say we have this different color. Let's say we have AB, same as last question, AB. Remember in the last question, P is on the line segment, right? But this time, I'm giving you a point that's not on the line segment. Let's say P is here, anywhere, P. How can we draw a line segment that's perpendicular to the given line segment using a straight edge and a compass? Okay. So the first step, we use a compass. The first step, we put the compass on the point P with a suitable radius, draw an arc to cut AB at 2 points C and D. So let's use this radius. Okay. Okay. AB is not long enough, so let's try to extend this. So I will call this, so I'll call this B. Okay. The arc cuts AB at C and D. So let's call this C. And let's call this D. Second step, with C and D as centers and a suitable radius, draw two arcs intersecting at E. Okay, so let's put the compass on C. let's try to draw an arc on this side, because whatever we're learning here, it's general. Okay, it's a general method. So technically, it doesn't matter where you draw the arcs, the method should always work. Okay, so this time let's just try to draw the arcs below the line segment. Okay. So let's just arc with the same radius, we draw an arc. Okay. And these two arcs, they intersect at point E. So let's call this E. And now we're claiming that if we join point P and point E, the line segment PE is perpendicular to the line segment AB. Okay, how do we prove it? How do we prove it? So now, like I said, it's very important to construct congruent triangles when we deal with straight edge and compass construction. Okay, so let's try to join all the points and form some triangles. Okay, now we have two triangles, right? PCE and PDE. How do we prove that PE is perpendicular to AB? We need to prove this angle is 90 degrees, right? Which means if we can prove that angle PC, let's call this, if we can prove PCF and triangle PDF are congruent, then we can prove that angle PFC is equal to PFD is equal to 90 degrees, right? I'm not going to write all the details because it's very similar to last question. So I'm just going to explain the proof verbally. Okay. The first step, we put the compass here and we draw an arc that cut A, B, and C and D, which means these two are equal. PC is equal to PD. Right? And then we move the compass to C and we chose a radius and we drew this arc. And we move it to D, use the same radius, we drew this arc, which means CE and DE are also equal. Right? And because PE is equal to PE, we can conclude that in triangle PCE is congruent to triangle PDE. You know that triangle PCE is congruent to triangle PDE. Right? And because these two triangles are congruent, these two angles are equal. So that means angle CPE is equal, sorry, angle CPE is equal to angle DPE. Right? And now, can we prove that triangle CPF is congruent triangle DPF. So now we know that angle CPE is equal to angle DPE, right? And we know PC and PD are equal. PC and PD are equal. And PF is equal to PF, right? So with these three pieces of information, we know that triangle PCF is congruent to triangle PDF because based on SAS, right? So this is an SAS, right? SAS. Okay, and that will help us draw the conclusion that angle PFC is equal to angle PFD is equal to 90 degrees. Okay, and then we can conclude that PF is perpendicular to CD. So this is how we prove this problem. Okay, so by now we have learned how to draw a line segment that's perpendicular to the given line segment. Okay, we learned two scenarios. The first one, the point is on the line segment. In the second scenario, the point is not on the line segment. Okay, we need to know how to draw a line segment that's perpendicular to the given line segment in both scenarios. Okay.